Because here we said that the triangle has two congruent sides. So the reason would be the definition of isosceles triangle. Okay? Remember, the definition of an isosceles triangle is a triangle that has two congruent sides. And this one has two congruent sides, so I can assume that this is an isosceles triangle. Now, let's move on to the next one. It says NO is the bisector of angle N. NO is the bisector or bisects angle N. So I'm going to put it here in the sketch that this bisects, so if this is angle N and this line is a bisector, this means that that bisector forms two new congruent angles. This angle and this angle should be congruent, because remember that the definition of bisector is a line that divides an angle into two equal parts. Okay? So what is the reason for that? Definition of angle bisector. Awesome. Okay, now let's think of what they are asking me to prove. They ask me to prove that the triangle MON is congruent with triangle PON. So remember that to prove the two triangles are congruent, I need to do it through the congruence postulate of triangles. And those postulates, let's recall them, who they were. They were SSS, ASA, SAS, AAS, and HL. Okay? Here we still don't know if this is a right triangle or not, so there's nothing we can prove with HL. We have until now one side and one angle. So we could use another side or another angle depending on where it is located. So think of what other conclusions can I come up with. From here, I didn't find anything else I can conclude. But is there anything that I can see from the drawing, from this sketch, that helps me find any congruent parts? Think. Okay, if you said that NO is congruent with NO, you are right. And yes, NO is congruent with NO. I know that sounds strange, but we've worked with that before. And is, let's write it here, NO is congruent to NO.